now let's get started. I'll switch my screen to the PowerPoint slide. And if you have questions, please ask them. And now is the best time to do it. Okay. Okay, so we have a new release. Sorry, a new two-digit release, StarRocks 3.4, right? Has packed with a lot of exciting new features. That has related to data lake analytics, related to query performance, related to our data ingestion framework, right? With our create table, there are a lot of changes, a lot of good changes, and also there are optimizations toward like AI ecosystem and machine learning related workloads, right? So now let's get started. So this is the agenda, right? So first, I'll spend 2 minutes max to talk about StarRocks for the users that are not familiar with it. I do see a lot of new names in this with the registration and deployment options and use cases, right? And then we'll dive into 3.4. We'll first talk about AI related stuff, right? Vector index, Python UDF, and then we're gonna go into data lake analytics, right? We're gonna talk a lot about caching, right? With Iceberg integration and optimizations, and then we'll talk about performance improvements. We do achieve 20% faster performance when compared to 3.4 on Iceberg tables, TBCDS 1 TB, the performance benchmark test, right? And then we're going to talk about data ingestion and table creation, right? We're going to talk about the optimized insert from files, um, ingestion framework and how that's going to replace the broker load, right? And then we're going to touch a little bit on security and stability, some new features there also. And we do have the release note on the StarRocks documentation, so definitely go take a look there because it has all of the links to the features, related features. So you can read the documentation. There are a lot of good examples in the documentation. I think that is the best way, for you to understand, those new features, right? So definitely check out the release note. And also in the StarRocks blog page, we also released a blog post about 3.4, right? A little deeper dive into some of the highlighted features with even more examples, right? So take a look at the release note and then take a look at the blog post, right? If you have question, raise them in Slack, okay? But now let's watch this webinar first, right? So first, StarRocks. StarRocks can be used as a kind of like a lakehouse query engine, right? You can connect it to open table formats and connect it to a open catalog service, right? And form like what people call it a lakehouse um, architecture, right? It supports popular table file formats like Delta Lake, Apache Iceberg, Apache Hudi managed Parquet files, ORC files, right? And it is designed to handle sort of like data warehouse, like customer facing, like low latency, high concurrency kind of workloads. Right? It has an MPP architecture, in memory data shuffling, so you can run joins at a scale, right? And optimize for low latency, and also is it's written in C++, is CMD optimized, so you get the best possible performance, right? It has a caching framework we're going to talk a lot about today. That's built, for cloud storage, right? For data lake storage, right? So you can get like data warehouse like performance on data lake houses like Apache Iceberg and Delta Lake. Okay, and StarRocks can also be used as a real-time data warehouse to support real-time analytics, those kind of like real-time workloads, utilizing StarRocks' own storage engine, right? And storage engine and file format, and its own table format, right? So first you get the same, not even the same, but even better, performance with StarRocks' own format, right? Sub-second queries at scale, best-in-class performance, right? And StarRocks is, I think, like until now, is the only real-time data warehouse that is built, to run join operations, join queries at scale, right? So you don't have to construct all of those like denormalization pipelines, especially when it's like in real time, right? You try to do that with a stream processing tool. That's a lot of work we don't want to do, right? And also the storage engine itself, the StarRocks storage engine itself, is able to handle mutable data in real time, right? You're able to do like sub 10-second data freshness with mutable data, right? With upserts and deletes, right? And that's powered by StarRocks primary key index, right? And also it features a storage compute separated architecture, so a shared data architecture. So all of the data persisted on the remote storage, and we have a caching framework that's on the CN nodes, on the execution nodes, to cache the data. So you get, good performance, but you get, remote storage, you get shared data architecture, right? So you're able to scale, and also you're able to save on the storage cost, right? So that's a quick rundown of what StarRocks is and what it does, right? And now let's dive into the 3.4 features. And now first, let's talk about AI ecosystem. So first, vector index, or more precisely AAN, proxy nearest neighborhood indexes, right? And those indexes are very useful for accelerating search, right? And that's really closely related to AI. Let's say you have some kind of unstructured data, and you have embedding model, right? You can embed that into, transform that into embedding, right? You have, let's say, 10 million images, right? So you get 10 million vectors, and you have a new image, right? And you want to search like which one of the image is the most similar to the one that you just that you have, the new one, right? So you do a vector search, right? You with a new vector and the 10 million vector that are stored, right? But just doing a brute force, iteration with all of them is just too expensive and slow, right? And sometimes we can, trade off, right? Trade off some accuracy, for like faster performance, right? This is where vector index really come in, right? And what I just described is basically reverse image search, and you can basically search everything and all kinds of unstructured data, as long as there is an embedding model that can, that can take care of it, right? That can accurately transform that unstructured data to a linearly separated vector, right? So you can search with so you can compare, the two with a like a linear distance metric, something like a Euclidean distance. I'm getting a little too deep here. Sorry. So yeah, so um so yeah, so the indexes are, like tools to accelerate this process at the cost of a little bit of the accuracy, right? And so we have two indexes that are supported here. So first is a quantization index, right? IVFPQ, and the next one is HNSW, right? Those two are very um, um, very widely used in the industry, right? The first one is a lot lighter, and the second one give you like really good accuracy with like still very good performance, right? And vector indexes are also very widely used in RAG system, right? We call it like LLM, right? So like ChatGPT, it doesn't really memorize things very well, right? The context window is not as large as people would want it to be, right? So you would just, you have a knowledge base, you basically turn your knowledge base into a bunch of vectors, right? And before you search ChatGPT, ChatGPT go to that that knowledge base, and basically to learn the context before answering your question, right? And that is called a RAG system, and that is very useful too, right? And so now you can use StarRocks for all kinds of search workloads and RAG, right? That's also a search workload. So you can do that all by just using SQL, right? So you can create a table and declare an index here, and you could just search, with pure SQL. And there are more examples on the documentation side if you're interested, right? So you don't have to like have a dedicated vector search, a vector database for your this kind of workflow. Star is able to handle them all, right? With quite good performance too. And we do have a webinar around a few months ago, right, from Tencent. They're actually the group that contributed this feature to StarRocks. And they used a whole like 40 minutes to talk about their scenario, how they use StarRocks to handle their reverse image search, to power their chatbots, and that's a very interesting webinar. So definitely go check it out on the Stellar Data YouTube channel. Okay. And the next is Python UDF, right? So Python is StarRocks has been more like in the Java ecosystem, right? We have Java UDF, and now we support Python UDF, so you're able to use Python functions and basically Python libraries, within StarRocks, in the SQL, right? So that's great, right? If you're in the Python ecosystem, and that's this will help you a ton, right? And this is the example here, and also go to the documentation. There are more examples over there. Okay, and then is Airfly support, protocol support. So before, let's say you want to retrieve a massive amount of result, right? A query result from StarRocks, right? So basically everything. So first, StarRocks uses a MySQL protocol, right? Which is not wrong, but it's role based, right? But when you're like getting a bunch of results, basically in a columnar format, right? So you have to transform that columnar format into row and then into column. It's very expensive and make things very slow, right? And the old framework bottlenecks on FE servers, right? So FE gets the data from B and then to the client, right? And that can bottleneck as well, right? And in version 3.4, we introduce Airfly, right? Airfly kind of protocol, right? So that's a columnar protocol, so that way it's a lot faster, and also you can directly talk to our BE nodes, right, and gets the data. So it's not going to bottleneck anywhere too, right? So it makes things a lot faster. So this is more of just a little more note of this, and this is going to be very helpful if you retrieve data using StarRocks, to feed your kind of like your machine learning applications, right? Massive amount of data. And this will be very useful and a lot faster. And this is an experimental feature, so when you use it with caution, right? And then is data lake analytics. A lot of updates here. So first is Iceberg equality delete support. So we do have this support in the previous version 3.3, right? But we did notice a lot of challenges, and mainly in performance, right? So equality is just a refresher. So basically, it doesn't, like when you do a delete, it doesn't actually delete, right? It basically stores all of the logical kind of like ranges of like what data are deleted, right? So basically a bunch of like logical operators there, right? That you store in the delete file, right? And basically the challenge is when there are a lot of like frequent upserts and deletes, right? It really degrades the query performance with StarRocks queries a V2 table with equality delete, right? And we investigated, and the cost is it when you query a very large amount of data, right? And it's very often that you're reading the same delete file over again, right? Because one delete file can represent like many data files, and that's the first, right? So you read that repeatedly many times. And also, I just talked about, like delete files has all of those like logical ranges in there, right? So which data are deleted positions, and not positions, but the ranges, right? And to merge, all of those, it's very expensive as well, right? To basically read the delete file itself, the operation itself is extremely expensive, right? So the two combined, it's just a very expensive process, right? And version 3.4, we made optimizations to handle this problem, right? So before, we didn't really have a dedicated like a read delete file kind of like scan node, right? So everything is handled together, right? So a scan node both scanned the data file, the data files that the range that it has, and as well as the delete file that are associated with this, right? So you have a bunch of scan nodes and a bunch of different data files. So delete files, that way you read them like repeatedly a lot, right? And then for each scan node, it has to do like an anti-join to merge the data file with the delete file, right? And that makes it very expensive, right? Doing the same work over and over again, right? And now for version 3.4, well, we introduced a scan node just for reading delete files, right? So we just read it once, and we read all of the data file once, and we perform anti-join, right? And that's just a lot more reasonable, right? You read a lot less duplicated delete files this way, right? So in scenarios, where there are, when you're reading a lot of files, a lot of data files, we can achieve multi-fold performance. But this number is really based on your own scenario and your own data distribution, right? So okay, so the next is asynchronized scan framework. So excuse me. So the challenges were we when you're reading a lot of data files, right, from a data lake, right? So when the FE try to retrieve the file list, it can bottleneck the whole system because it has to generate all of the scan ranges for all of the query plan, right? The query physical query plan, and all of the fragments, all of the fragments with a scan range, down to the BE or CN nodes, right? Before BE can start working, right? So FE can bottleneck the whole system very easily, right? Because it's stuck at like reading all of the files, reading all of the file lists, right? And we did the optimization there. Basically, FE and BE now can work asynchronously, right? So FE is not going to bottleneck the whole system this way, right? So and this really reduce code query latency, because first time query, when the metadata cache is empty, right? That's when the reading the file is it takes the longest amount of time, right? And also can maintain a smaller cache, right? So basically reduce memory pressure. FE, like FE memory is very valuable, for StarRocks, right? While maintaining, the same or even better query performance. So this is the async scan framework. And then we have data cache, right? Data cache plays a very pivotal role in StarRocks, both in terms of I talked about real-time analytics with the shared data architecture, right? And also with querying data lake, right? You basically you cache the files on your B or CN nodes, right? So you don't have to go to remote storage to grab the file, so faster query performance, right? But there is a challenge, right? So basically, when you have a cache, right, and what if there is like a huge query, scan like 80% of the files, and basically it pollutes your cache, right? So we introduced segmented LRU to basically to prevent this from happening, right? So basically, the cache space is divided into an eviction segment. So basically, the LRU here, and a protected LRU segment, right? And both are managed, like both use LRU, right? Strategy. Okay, so basically you have a data entry here, right? The first time it goes into the eviction or the regular LRU segment, right? And when it's the second time, it comes in the second time, and then it gets protected, right? So basically here they get one strike, right? And they're out first. And if you it's the second time, the cache is in when it's already in the RU, it's in the protection segment, right? So it decreases the chance of good hot data being evicted by accident, from a large query, right? So it reduces cache pollution, caused by large queries, and improve cache hit rate, right? It also minimizes, query performance fluctuations, right? You see a lot less slow queries. And the test results are really, this one is like 100% case by case. It depends on like your data distribution and what your query look like, right? But in our test, it can be 70% to multifold, right? And it really help you stabilize performance. Okay, so and next is adaptive I/O for data cache, right? So first, um, data cache uses memory and disk to cache the data, right? And to evict and to accept new cache, new data, right? And sometimes when the disk pressure is too high, right, it can bottleneck the system, right? And here we introduced a strategy basically uh, uh, to read directly, from remote storage, right? Instead of the cache, when the cache is already overworking, right? Already too much pressure, right? So it can increase system throughput in very high load scenarios, right? And also this can lead to one time to multi-fold query performance gain, according to our test. And again, this is case by case as well. It really depends on your own setup. Okay. And next is data cache ease of use, right? And this, we finally did it. We unified data cache between our shared data architecture and the data lake queries for data lake cache, right? So basically, so before, um, if you want to run both, let's say Apache Iceberg queries and let's say StarRocks shared data queries, right? So what you would do is you reserve. So first, the parameters are different, right? So you have to like two sets of learn two things, and also the monitoring are completely separated, right? And also you have to reserve cache space for those two kinds of workloads like completely separately, right? And now everything I just talked about, including configurations and metrics and cache space, all of those are unified into one, right? So this way, it simplifies your configuration process, and also you don't have to reserve resources for each kind of workload independently. So ultimately increases your resource utilization overall, right? Okay, and here let's talk a little bit about performance, right? So we did a lot of targeted query plan optimization for common query patterns on the data lake, right? So basically for joins and aggregations, right? So when you create an external catalog with StarRocks, let's say connecting to Iceberg or Hive external catalog, like trying to create Iceberg table, right? You can declare primary key and foreign keys constraints, right? And in this version 3.4, StarRocks can actually utilize those foreign key and primary key constraints to basically to do column pruning. So you read less column, right? And do table pruning, right? Some of the table are not even useful, right? And this really accelerates query performance, but this depends on your own query scenario, right? Your own query pattern, and your own data, your schemas, right? And also we did a lot of optimizations on aggregation pushdown, right? Optimize, where that actually happens, and many other performance improvements. You can read all of those in the release note and in the documentation, right? But overall, so out of box TBCD as 1 terabyte Iceberg, a benchmark test on Apache Iceberg, the query performance improved around like 20%, right? And this is significant improvements. So definitely go try 3.4 out, right? And benchmark it yourself on your own scenario, on your own use case. Okay. And then is query feedback. All right. So StarRocks is able to continuously collect slow queries and analyze those query plans and provide tuning recommendations, right? And the recommendations can be done either automatically. So automatically to run the query like many times, automatically optimize the query, right? You can see here the plan has been tuned by plan advisor, and and this means that this has already been tuned, right? You can do it automatically, or you can do it manually, right? You submit a SQL and have it like give you suggestions, right? How to improve it, right? And this is query feedback, and this is a um uh let's say the first step of observability, right? And query performance of observability. And we're gonna really try to work on this aspect in the future, right? For those like customer facing like workloads, right? We really want to solve those slow queries to stabilize your query performance, right? And also data lake queries now supports automatic statistic collection, right? So it's gonna automatically trigger, the analyze uh, external catalog, task uh, based on when the user run a query, right? So it's able to provide a lot more accurate statistic when compared to like just what's in the metadata file, right? So optimizing query plan and per query performance, right? And this works completely out of box, so you just know it's there, but you don't really have to worry about it, right? And also we worked a lot on data lake ecosystems. We now support creating and deleting branches and tags for Apache Iceberg, right? And we also were able to do time travel. So query by a timestamp or by a version. So query the data that were historical data, right? So you can use StarRocks to easily retrieve past versions, and you can use that to recover deleted data, right? And that's all of the things that's good about Apache Iceberg, branches and tags, and now StarRocks support, right? And also for Delta, now we support column mapping, right? So when the Delta Lake table that has undergone like a schema evolution, a StarRocks can still create that table, right, without any change in the external catalog declaration, right? So this is data lake, right? And now let's talk a little bit about create tables and data ingestion. And this is related to StarRocks' own storage engine. Okay, so first is store generic aggregate states, right? It's a long name. So basically, the problem with StarRocks aggregated tables were it only supports a few kinds of aggregated functions, right? Something like a sum, right, or a min or a max, out of that, only a few more functions are supported, right? And now we did this new framework, for us to add support for other kinds of aggregated functions, right? Now it supports almost all kinds of aggregated functions. I'm gonna use the next slide to talk a little bit about, the theory that's behind this, right? Now it supports almost all aggregated functions, and there's still a few that's not supported. Just go into the documentation and take a look. All right. So also supports query rewrite, right? Not only aggregated tables, and that's supported in async and sync materialized view as well, right? So how to use it is so this is create an aggregated table, right? So it's very similar than what it was before, right? So the V here, so this one is a regular, aggregated table, is using 3.3. Some was already supported, right? But here, it's a new one, right? So the new general aggregated function, right? So you want to do an average, which is not supported before, right? And you want the result to be in this data type, right? So you just declare this in the create table statement. And so the reason why a lot of the aggregated functions are very difficult to implement, because like aggregated table is incremental, right? So every ingestion, you're not storing all of the historical data, right? It's because let's think about like something like min or max or sum, right? You don't really have to uh, maintain a state, for those three, to work, right? So the min max, you just leave that one number there, right? And your new value come in, like how is that gonna change the value, right? But it's different for most of the aggregated functions. It needs an intermediate state, to be able to basically to update, right? Let's talk about something like an average, right? So average would be, the sum of all over the count of all, right? You have to have like that intermediate state in order to compute, the right value. And something that's more common is count distinct, right? You have like a value like 50, right? And you have a new value coming, you don't know like if it's distinct or not, right? So the intermediate state for like a count distinct would be something like a deduplicated list of the values, right? And then you do a final count, when the user actually wants the aggregated value, right? So this is what the framework basically look like. You have the original values, so in the raw format, right? And you transform that value into an intermediate state, and then from that you can get the final value, right? And this is how this framework basically works. So when you ingest your data, you use the transform and store, you use the state, right, function. So basically whatever that column is called, you just add a slash state here, right? And this is going to transform your raw data into an intermediate state, right? And when you want to get the final result, we actually query the data, right? You use the merge function, right, to do the final merge of the, let's say for an average, right? This would be internally, that would be a sum, so the sum over count, right? So, and then you have the average, right? And StarRocks maintain that intermediate state. But in some cases, you do want to get this intermediate state, maybe to insert that into another table, right? And that's when you use union, right? And this basically, you just get intermediate state out, and then you can basically to ingest this into another table, right? And this sometimes this is all like coded, but StarRocks knows the code, so you get into another table still works, right? But for majority of the users, state and merge is all you need, right? To basically to utilize all of the aggregated functions that StarRocks provides, right? With aggregated key table, with single table materialized views, right? And this is very useful. And the next one I want to talk about is insert from files. We do have a broker load function that used to be using for a very long time, right? And we do want to use insert from files to replace broker load, right? And we're doing a lot of enhancements into insert from files, so you can actually, use SQL to do all of your data ingestion, right? Instead of like a task, and Linux commands, and nobody likes those, right? And so first, insert from files now supports a remote, like just basically exploring your directory and files without actually ingesting into them. I'll have an example later. Just can't fit everything here. So you can easily inspect and validate the data, before you actually do the table ingestion, right? And also you can you can do the insert by name, right? You have the column mapping. So basically, before when you do an insert from files, you have to use position match. So basically, you have to the columns in the insert has to match the columns in the table, directly one by one by position, right? And now you can basically do an insert from files and select star, right? Because it's gonna automatically match the table columns by name, right? And also we support the from files. The files support union files with different schema. So basically, what this means is that if you have files that's sitting in your S3 that has different schema, right? StarRocks is able to automatically match the schema between the files and then do the ingestion, right? And a good example of this is let's say you have a bunch of Parquet files there, right? And before you have two columns, and somehow your business changed, you need to add a new column, right? So there are some files that are two columns, and there's some files that are three columns, right? And when you want to do like a historical, like a batch ingest into StarRocks, before that's not gonna work because the schema doesn't match, right? But now it's gonna take the one with the most take a union of all of the columns, right? Basically, if the file doesn't have each one of the columns, it's going to be a null value, right? So it's very useful, for like a historical data ingestion, right? Batch ingestion with the data that's undergone a lot of like schema evolution, and this is gonna work very well for that, right? And we also added new property clauses. Some of them we're probably familiar with those: a strict mode, error filtering, timeout control, for better management and better ease of use, right? And also the insert override seen. Oh, I think that I need to that should be a new slide. But insert override has gone some optimization as well, right? So before you can either do an insert override over entire table, right? But if a a, a partition um does not exist in the new one, it's just gone, right? It's just deleted. The whole table is truncated. Uh, and or you can do it by manually. You basically insert override by a specific partition, right? So that manually you can protect those partitions that doesn't you don't want to change, but you still want to leave there, right? But right now it has automatic partition detection, right? So you can to basically insert override an entire table, right, without actually without deleting the partitions that are not here, that are not in the new data, right? So that's very useful as well, right? So here are some examples for the insert from files, right? So you can basically start from select from files. You can uh, you can you can view all of the data files that are there, right? You can view the data schema that are there, and you can use a simple create table as select, to create a table and load some data in, right, with insert from files. And personally, I think this is much more usable than the broker load functionality. That's still there, but this is a lot more easy to use, and this gives you a lot more observability into what you are actually ingesting, right? And then this is what it looks like, with the by name, and what it looks like with the file, the union file. What's that called again? Union file with different schema, right? So basically, you create a table and you insert into. You don't have to like worry about how the column between the two matches, right? Because it's StarRocks gonna match it for you, and also you don't have to worry about the files having different kind of schema, right? And StarRocks will resolve themselves, internally. And to learn about like how this works in detail, go to the StarRocks documentation and take a look at insert from files, right? Has a few more examples there that can help you understand how exactly does it merge files, and how exactly does the by name works. Okay, next one. So security and stability, right? So we do have a lot of some. We're always working on security and stability for every single version, right? So first we introduce graceful exit function, right? It ensures the queries are uh, when the B and C and like exit for a short period, the query doesn't crash, right? So so it keeps executing. Okay, so it basically can help you minimize business impact. When you do a upgrade, or do a B upgrade, right? And so basically improve your system availability, right? And then follower FE now supports checkpoints, right? So it really reduces memory pressure on the leader FE, right? So it enhances system stability. And also we've done more work on StarRocks FE in the version 3.4, like how it prints log, right? And other improvements to improve stability and overall performance, right? And for backup, we also have new backup that we support, right? From backing up logical views, to backing up external catalogs, and to backup tables with expression and list partitions, which were not supported before, right? And now you can back up a lot more stuff, right? And also it receive a performance boost, right? Up to 1 GB with a big B per second backup speed per node, right? So it's gonna meet most of your use cases. Okay, so that's all I have. Any questions? I'll go back to the. Oh, that's a lot of questions. Let me take a look. Okay, now let's first take a look at the audience chat. So here, basically, top K hot hitters are protected. How common query patterns are collected? I think this we're talking about the. Wait, let's see. Where's my cache? Yeah. So, uh, yeah. So top K, actually the top. Yeah. So the top. Yeah, I think that makes sense. So top K hot hitters are protected. So yeah. So we do have. So now we have like a hierarchical two-phase. A cache, right? So if you a cache, if something is already in the cache, it gets queried again, right? Goes into the production stage, which is a lot more difficult to get evicted because you have to get evicted from the protected segment first, right? And then the regular segment, and then you go, right? So yeah, so top K hot hitters are protected. That makes sense. And how common query patterns are detected, collected? Um, I Any frequency more than two are protected, right? You think? No, it has to be like consecutive, right? So you cannot have like you query something and then it gets evicted and you query again. It's not gonna go into the protected segment, right? Does that make sense? Okay, so how common query patterns are collected? Oh, so that's not really I know this is the slide you were talking about, I think. So this, right? Yeah, so this basically common query pattern is just a query pattern you guys use, right? So basically that basically means faster queries, right? Doesn't really mean anything specific. So we do work with a lot of you guys, so we know like what you guys need, in terms of performance, right? So that's basically how we choose what to optimize. um yeah, no, I'll go through this first and go through the QA, and this time I'll promise I'll follow up with all of the questions we cannot handle, here. And could you please send questions to Q&A above? Do not lose. Oh, okay. Thank you, Lexi. So basically, I'm gonna save all of the chat history and the Q&A, and I'll go back and the team is gonna reach out, right? Uh, okay. Now let's look at the Q&A. Okay, so first question: How can I ensure? Oh, this was how can I ensure deleted rows in Parquet files are also removed from StarRocks table when ingesting data using StarRocks PIPE? Currently, when an update occurs, all data remains in the table instead of being deleted. The files, I think, deleting something, it reserves the file. It's so all of the deletes in StarRocks are logical deletes. I think that's what's happening. But so you still have removed Parquet files over also. Yeah. So the files are not Parquet files. So I'm gonna need a little more information on this. So the rows in the Parquet files are removed from StarRocks table. So I think you're connecting to some kind of like a data lake, right? Um, you have your Parquet files there, and that Stars doesn't support like deleting files for all of the data lakes. So it really depends on what you use. In just using pipe, like how do you have Parquet file with pipe? You know what? I'm gonna follow up with you later on this. Um, um, I'm gonna need a little more information, right? Uh, Slide deck for download. Yeah, sure. I'll include the link of the this slide when I send out follow up emails. Okay. Um, can we use insert into plus files very frequently? Data ingestion pipeline generates one every 5 minutes per table. We don't want to use. I think 5 minutes. That's okay. Does Python UDF only support scalar functions? Right now I think the answer is yes. And on the roadmap, I'll check with the I'll check with the team. I'll get back to you. Okay, this one already answered. PR. Okay, this is a very specific question. So it's PR 49000 aggregated state for UDAF performance improvements only in 339, not in 340 yet. I'll have to check with that. Yeah, I'll follow up with you. Are you in the Slack channel? Be sure to join the Slack channel with if you're not here already. I think I have your contact. I'll follow up with you later. How do we define slow queries? How do we define slow queries? Latency is higher than the others, I guess. So slow query. So basically, how do I put it? So it really depends on your scenario, right? Like say if you're running something like customer facing, right? Everything is like sub 1 second, and because your cache is polluted, and one query is like 15 seconds, and that's a slow query, right? And 15 seconds might not be slow for some other kind of use case, like a data scientist trying to do some data exploration, right? Like with a lot of joins and aggregations on the fly. It really depends on your scenario use case. Um, if I want to maintain multiple aggregate tables from the same source fact table, is there a good solution to avoid multiple scan? Wait, let me go to here. Wait, I lost my questions. Just in a sec. There's so many questions. I can't find. I couldn't find the one that I was looking at. Sorry. I'll get back. I'll get back to it in a little bit. Is there any plans to support AVRO formats with files command? I don't think in the near term yet. But let me talk to the team and I'll give you a more concrete answer on this. Indexes and materialized views improves query performance, but I can't find how exactly it increase size. Anything concrete on there? I think it's in the like for indexes, those are in the documentation, right? Check out the documentation. But for materialized view, it's really, that's really the 100% case by case. I can't really say like 100%, like how much each one is gonna cost, because if you run like a denormalization, that's gonna cost a lot. Um, let's follow up with with your specific scenario, and then we can talk about how much space it's gonna need, right? Does the union column in insert from files cause performance degradation? I know this DuckDB read much slower with union by name is turned on. Yes, a little bit, but in our test, we don't notice anything that's very significant though. How about you can give it a try, and if you um see any problems with the performance, let us know, right? It shouldn't. Can materialized views support joins? Can materialized views support joins? So we have two kinds of materialized views. One is a single table aggregated, so everything is like incremental. So that's what the generic aggregate state, that thing is built for, right? Everything's incremental, and that thing does not support join. And we do have and that's a synchronous materialized view, and we do have another asynchronous materialized view. You refresh by partition, right? And that thing supports all of the SQL queries you can basically imagine. Actually not, but but it does support join. Any plans to support group by all and select star? Exclude column. I remember somebody talk about this too, though. I can't remember. Let me follow up on you, Victor, on this. Okay. Any plans to adding AWS QuickSight integration? Currently, StarRocks is not fully MySQL compatible, so using MySQL data source is buggy. Yeah, we'll follow up on that. I'm not really familiar with this tool, so yeah, I'll find the right person and follow up with you on that. Any known initiative for direct data extraction for enterprise RDMS, Oracle, MySQL, and this I don't think in the open source version, but I'll follow up with you on that as well, right? Okay, did I miss any question? I probably cannot. A lot of the questions are detailed, so I'm probably not going to be able to like answer all of them like here. But definitely, we're gonna reach out, in the email, with all of the follow ups. Do have a lot of questions today. Thank you. Thank you guys for coming, and go try out 3.4. We have a Docker. That literally like one line of command. Give that a try. Give the new features a try. And it's been fun. This session. Thank you guys for all of the chat messages and for the questions, and thank you so much. And we're going to reach out for follow ups. Thank you. See you guys next time. Thank you. Appreciate that. Really appreciate that. Thank you. Bye.